Okay, ladies and gentlemen, we are going to learn how to apply the product and quotient rules to problems that have exponents. Before we get deep into the product and quotient rules, I'm going to need you to take your note sheet and I need you to flip it over because I have some quick review questions that I want to go over since it's been a while since we talked about the parts of an exponent and how they work. So your note sheet has this line down the center. When you flip your paper over, you want your quick review to be all the way to the right, actually, when you're doing this. Okay, so the first thing you're going to write down on that back is the problem 6 to the third power. Sometimes we read this as 6 cubed because 3 is your exponent and the base is a 6. And exponents, the way they work is exponent tells you how many times you're going to multiply out your base. So that's why this is equivalent to 6 times 6 times 6. And if you remember being able to use your calculator, if you want to multiply 6 times 6 times 6, you can, and you can get your solution. Or you could take 6 and you could raise it to the power of 3. And remember that caret button over here is what's going to allow you to quickly and easily do all kinds of exponent problems. So 216 is the value that we get for that question. And I'm just going to go back. I think I'll write it in because I don't want to spoil what we're talking about next. When you look at the next part of my quick review, we've got to talk about how sometimes, and it's strange to have this, but sometimes we have an exponent that's a 0. And in math, any number raised to the 0 power actually has a value of 1. We'll discuss why that is soon, but doing examples, it doesn't matter, again, what number it is. 6 to the 0 power is 1. 15 to the 0 power is 1. Even 8,375.623 to the 0 power is 1. Even an irrational number like pi raised to the 0 power is 1. And if you'd like to verify that on your calculator, remember we said 6 to the 0 power gave us 1, 15 to the 0 power, and so forth. So one of the good things is we can check that against our calculator that anything to the 0 power has a value of 1. So those are the two things I wanted to review. The next thing I wanted to do, coming back to the front page of your note sheet, is make sure you understand how to apply what's called the product rule, and then we'll take a look at the quotient rules after that. So guys, sometimes you're going to be given problems like this. We've got 2 squared and we want to be able to multiply by 2 to the third power. Now yes, we can go to our calculator and we can type this in, but sometimes we're not interested in the actual answer. We're just interested in making this a smaller, nicer looking problem to work with, because that's what we do a lot in math, remember, is we take a big complicated problem and we neaten it up as much as we can. So here's one thing we could do. We could take what we know 2 squared to be and we could write it out. We know 2 squared is when you have 2 times 2, so I showed you that here in purple. We could also take this part of the problem, 2 to the third power, and we could write that out in the green, showing 2 times 2 times 2, or 2 cubed. Now, what's neat about this is we haven't really made it nicer looking, but we have laid it out so we know exactly what we're dealing with. We are dealing with 1, 2, 3, 4, 5 different 2's that are being multiplied together. So using what we know about bases and exponents, we would take our base 2, and we would show that our exponent is now a 5. Now, if you noticed, there is a little shortcut with this. We didn't have to write all our factors out every time. We could have just taken our exponents and we could have added, hey, I've got 2 here plus 3 here, means I'm going to have 5 altogether. So this is the product rule. If you have a multiplication problem to do with the same base, you are allowed to add the exponents as long as you keep the base the same. So again, this is what's called the product rule. And the product rule is used a lot in math, just like PEMDAS is used a lot to simplify lots of math problems. Product rule is used a lot to simplify exponent problems. Now, what we have next, I don't want to ruin the solution, so I'm actually going to erase this for a second. Okay, I want to show you again what you could do if you wanted to write out all the values. X to the 5th is 1, 2, 3, 4, and 5 different x's. And it says we're multiplying it against x to the 3rd. So that means 1, 2, 3 more. Okay, again, this takes a lot of time. If I look at what I have all in a row here, there are 8 of them, so I can use my base and my exponent to show that yes, there are 8. Again, shortcut is just go ahead and add 5 plus 3 to give me 8. So if you're comfortable, you can go ahead and use that shortcut, which is called the product rule. And if you prefer, you can still take the time to write out all the factors. Go ahead and try the next couple. By pausing this video, you can try them on your own, and then you can hit play to check your work. Okay, now that you've tried a couple on your own, let's see. Did you leave the base 9? And did you add your exponents to see that there would be 6 altogether? If you wrote it out, your work probably looks something like this. 9 squared would be represented by 9 times 9. And then 9 to the 4th would be represented by 1, 2, 3, and 4. So all together you can see that we have 6 of those bases that are all 9. So 9 to the 6th power is a good way to write this problem's answer. Now this one's tricky. Most students mess up with this because they see the 6 and then they don't really pay attention to the fact that they have one more y over here. If you were to write out the factors for this one, you would write your initial y, and then you would have y to the 6th sitting next to it, and then you would probably agree with me that it totals up to be y to the 7th power. So again, we have to make sure that we remember there's one more y there. We just typically don't write the exponent of a 1. Now for this one, it's pretty tricky because we have to remember that anything to the 0 power has a value of 1. So technically the problem given to us is that we have n to the 7th power times the value of 1. Anything times 1 is just the number that we started with, n to the 7th. So we don't have to write that one out if we don't want to. Now the last one is similar to what you'll see next year in algebra. In algebra, you not only have letters with exponents, but sometimes you'll have this number out front called a coefficient. Coefficients get multiplied together just like they always have. 2 times 3 is 6. The variables that have the exponent, and again, this exponent is only attached to the x's. We have x squared, which you know that looks like this, and then we have x cubed over here. So once you set them all up, you'll see that we only have 5 of the x's. So x to the 5th, the coefficient, remember the number in front, is going to be a 6, because 2 times 3 gives us 6, but we don't actually multiply our exponents, we always add our exponents when we have a problem like this. So that one you probably missed, but that's okay. It's really a question for algebra next year. So now what we're doing is we're going to take a look at dividing expressions that have the same base. So for the first example, I've given you 4 to the 5th power. So we're going to take a second and we're going to write out what that actually means. 4 times 4 times 4 times 4 times 4. And on the bottom, we just have 4 times 4 times 4. So one of the things you learned about fractions in elementary school is that a number divided by itself will cancel out and give you 1. We have another pair of a number divided by itself, and we have a third pair. What we don't have is anything that we can cancel with these 4 times 4 on top. So remember, the way to write our answer, if we have matching bases, is to say that, hey, I've got 2 of them. So the answer would be 4 squared. Yes, we can equal this to 16 if we want to, but right now we're focusing on what's called the quotient rule. The quotient rule actually has us subtract our exponents. If you see what we did up top, we were canceling numbers that divided by themselves, but if you think about it, we had 5 to begin with. Since we canceled out 3, we were actually subtracting the 3 that were on the bottom. So 5 minus 3 gave us our 4 squared. The base must stay the same. Started with 4 to some power and we ended up with 4 to some power. But the shortcut for this rule is that you're allowed to subtract. And the subtracting again just comes from the canceling that can be done. So for this one, we're going to write out all our x's. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you know why we like to use the shortcut rule, because it's a pain to have to write this out every time. 1, 2, 3, 4. Okay, so that's what it means to have x to the 9th, x to the 4th. What we want to do now is we want to cancel out all these values that would divide out and cancel anyway. So we have 1, 2, 3, 4, 5. We have x to the 5th left over for that problem. So again, we just use the quotient rule. And a shortcut would have been to just leave it the way it was. 9 minus 4 is 5. And we're done without having to write this out. So try the next couple of examples. They get pretty tricky towards the bottom, but pause the video. Try them on your own anyway, and then check back in to play it and check your answers. Okay, so if you're following along, we did this one together, and over here we need to remember that y to the 0 power has a value of 1. So anything divided by 1 is just that thing we started with. So we don't have to write out the factors of y to the 5th if we don't want. It's going to be simply y to the 5th when we're done. For this one, I could have written out the factors. We had 3 times 3 times 3 on the top, and on the bottom we just have 3 times 3. So by the time you get done canceling these, you're going to see why I ended up with 3 to the 1st power. However, we typically don't include a power of 1, so we could just say the answer to that one is 3. This one's a little tricky because we have coefficients like we talked about on the other page. So I separate my coefficients. 9 divided by 3 is 3. And then I focus on looking at my bases that are the same. If I have x to the 5th and I have x squared, I'm going to be canceling out 2 of my x's. 5 minus 2 gives me x to the 3rd. So again, I can use my quotient rule to save me the time of having to write that all out. Now for this one, I'm going to focus on just the numerator first. I have like bases. I'm multiplying them together so I can add my exponents using the product rule that we learned about on the other side of the notes. But I still have the 7 to the 3rd power on the bottom of a fraction, so that allows me to use my quotient rule. If I have 7 on top, I'm going to be able to cancel with 3 of those on the bottom. So 7 minus 3 gave me 7 to the 4th. And then in this example, we actually have to use our quotient rule first. Bases are the same. 4 minus 2 gave me 2. And then I've still got to multiply by 15 to the 7th. So again, if I wanted to write it out, I could. I'd have 15 times 15. I'd have 7 15s here. But all in all, I can just add them together using my quotient rule and get 15 to the 9th. And then on the bottom, this is a little preview of what we're going to be talking about soon, is sometimes you have more of the factors on the bottom. In this case, we had 6 to the 5th power. And on the top, we had 6 to the 3rd. So something to remember is that when these cancel, you're really leaving behind all these little 1s. 1 times 1 times 1 is 1 for our numerator. And this time, the 6 squared got left behind on the bottom of the fraction. So if we simplified a little bit further, we would say that this is equal to 1 over 36, a very, very small value. So go ahead and tape these into your notebook. I believe we're on page 123 and 124. Your title is that you're learning about the laws of exponents. And then this page that you did the quick review problems on the back, just make sure you tape it over here to the left so that you can still open it and review some of that basic information we went over first. This one can get taped down normal.